Good day, guys, and welcome to Intellect Academy. And we have two problems here on the board to solve, and of course, we have question. Let's say it's question number one, question number two. So we're going to solve that now, and of course, let's start with one. So we're having question number one. If you resolve x-1 into what? Partial fractions, of course. Okay, so first of all, now which type of partial fraction is this? You can see that the denominator is what? A quadratic equation, right? Of course, is of the roots, is of the equation x squared plus 8x plus 15 equals to 0. We have to do sum, we have to do product. Which two numbers that when we add, we're going to have 8x, and when we multiply, we're going to have the product of these two, which is 15x squared. Which two numbers? Now let's think of a number that ranges from 1 to 10, two numbers. Okay, let's do 4x plus 4x. 4x plus 4x will give us 8x. But if you multiply these two, it will give us 16x squared. So therefore, normally it's supposed to give us 8x here and it's supposed to give us 15x squared. Right? Which two numbers that we're going to use? Let's use 3 and 5. 3x plus 5x is equals to 8x, right? Is equals to 8x. But if you multiply 3x by 5x, you have 15x squared. Okay, yes, we've gotten the numbers. We've gotten the two numbers that when you multiply and you add them, they will give you this and the product of these two. Okay, now let's wipe this up. So we have x squared plus, of course, 8x, two numbers, 3x plus 5x, then what? Plus 15 to 0. Of course, we break this down. We're going to group this and we're going to group this. Of course, grouping this, we're going to factorize x out from here. So we bring our x out, you'll be having x plus what? 3. Of course, here you notice what is common here is 5. We bring out positive 5 out, you have x plus 15 divided by 5 is 3. Of course, very important, we have made these two brackets look alike. We're going to take one of them. Take one, we have x plus 4, x plus 3. Then we're left with what? This and this, x plus 5 equals to 0. So therefore, I've gotten a linear, more of like a linear factor. So we're going to put this in place of this. We have x negative 1 over what? X plus 3 and x plus 5. Of course, this is the concept. A quadratic equation, quadratic factor can be simplified into this. Now, for us to go on, we're going to assign this a over what? X plus 3 plus b over what? X plus 5. We have solution here. So using substitution method, we're bringing everything out. So we're having x negative 1 over what? X plus 3, x plus 5. Of course, assume to be what? A over x plus 3 plus b over x plus 5. Of course, we have gotten this. The next step is what? To take the LCM. So taking the LCM, we're having x negative 1 over what? X plus 3. We have x plus 5. Assume to be what? Taking the LCM. The LCM between x plus 3 and x plus 5 is what? Joining them together. So if we join it, we're going to use a over x plus 3. Going to multiply by what? X plus 3 and x plus 5. This will cancel this. So we're going to have a multiplied by x plus 5 Then for the other one, which is the same method of this multiplied by this and this multiplied by this, we have b multiplied by x plus 3 over what? X plus 3 bracket x plus 5. Now you can see that thus will cancel this and you're left with what? X negative 1 is assumed to be what? A bracket x plus 5 plus what? B bracket x plus 3. Now, of course, the method of use substitution comes into here. What are we assuming? What are we substituting? Take note. For us to eliminate b and make A's Survey formula, at what point must b be equals to 0? Be rendered 0. Of course, if we say let A's be equals to negative 3, we will see that here will be rendered 0, right? So let's do that. Substituting this, we're having negative 3, negative 1 is equal to what? A bracket negative 3 plus 5 plus b bracket 3 negative 3. Of course, this is out, rendered 0. So here we have negative 4 is equal to what? Now we have a into what? Negative 3 plus 2 plus 5 is what? 2. So therefore, if we divide both sides by 2, 2 into this 1, 2 into this 2, we see that our value of a is equal to negative 2. What did you notice? At what point must, back to the equation, very important equation. So let's asterisk this to know we are working with this. At what point will a be equals to 0 here by substitution? Okay, a will be equals to 0 by substitution if x is equals to negative 5. So we're going to assume x is equals to negative 5. So we're having let x be equals to negative 5. So we're having negative 5, negative 1 is equal to what? A bracket negative 5 plus 5. I made a mistake here. This is supposed to be negative 3 plus 3, which is in turn rendered this 0, but it's still the same concept. And so we have here what? Positive b into what? Negative 5 plus 3. Of course, this will be negative 6. This is out, 0 is equal to what? Negative 2. So you have this becomes b is equal to what? Negative 6 over negative 2. Negative equals to negative 2 into 2, 1, 2 into 6, 3. So b is equals to 3. Of course, I'm going to substitute those values from assumed this thing. I will say that x negative 1 over what? X plus 3 x plus 5 is equal to what? A is what? Negative 2. Negative 2 over what? X plus 3 plus what? B. B is 3. So we have 3 over x plus 5. Of course, in this case, we see that positives will come before negative. So we have the x negative 1 over what? X plus 3 x plus 5 is equal to what? 3 over what? X plus 5 negative 2 over x plus 3. So therefore, this is the way we solve the method of substitution. Now let's jump onto the second sample problem I are given here. I lay emphasis on which type of partial fraction is this. Of course, look at the denominator. Of course, the denominator in this case is a repeated linear factor, in the sense that you're having x negative 1 repeating 3 times. Of course, I told you that if you have a case like this, you break this down into 3. Now, for example, I told you that you have a case like this. Assuming this, we're having a over what? X negative 1. Of course, for the first, we have plus what? B over what? X negative 1 squared. For the second, we have plus what? C over what? X negative 1 for the third. Of course, we said this is the way we solve this. And of course, which method are we going to use to solve this? Which method is suitable for you to use? Now, I advise you not to use the cover-up method. Don't use the cover-up method to solve this. Don't use it. Don't use the substitution method to solve this. Use the method of equating the coefficients. Method of equating the coefficients. The best method to solve this is using the method of equating the coefficients. So first of all, we say this is what? This is a repeated linear factor denominator, and the method we must use is we're going to make use of what? Method of equating coefficients. That is the method we use, or we must use. Very important. That is the method we must use. Do not use cover-up method for repeated linear factors. Do not use substitution method for repeated linear factor. Use what? Method of equating the coefficients. Now, let's go on to solve this. Of course, in this case, we have what we have here on the board, x negative 1, 3. We have assumed this. The next step is to take what? The LCM. Take the LCM. Of course, it's very easy to understand. The LCM between all this is this, right? So we're going to use this to multiply what we have here. If we use x negative 3 all cube and multiply a over x negative 1, 1 will be left, right? So we're just going to have what we have here, assuming a bracket x negative 1 squared, because we have 1 down. If you look at this now, if we use this to multiply this, 2 of this will go out and will be left with 1. So we have plus b bracket x negative 1 will be left with 1, right? So it's going to be of this order. But now take note, the LCM of this is what is attached down. So this is going to cancel what we have here. So therefore, you're just going to be left with only c. You understand the concept, right? Let me make you understand it better. So if we have a over what? X negative 1 multiplied by the LCM x plus x negative 1 all cube. This will be 2 and this will be 1. So that's why you're having a bracket x negative 1 all squared. For the next one, if this is b, so for the next one we have b over what? X negative 1 all square multiplied by the LCM x negative 1 cube. This will cancel this, you're left with 1. Then for c, you see that everything will cancel the LCM. So then, so divided by what? The LCM, which is x negative 1 cube. What do you notice? The same denominators will cancel out. You have what? 5x negative 7 is assumed to be what? Equal to a x negative 1 square plus what? b x negative 1 plus c. Now, when we reach this step, we're going to open the brackets and expand. First of all, we're going to expand x negative 1 all squared. If we're expanding this, we have a bracket what? Using binomial expansion, this becomes x squared negative what? 2x plus 1, right? Plus what? b x negative 1 plus c. Of course, also I'm going to open the bracket, so we have a x squared negative 2a x, a multiplied by 1, we have plus a, plus what? B multiplied by x, we have bx, plus b multiplied by negative 1, you have negative b, then plus c. Of course, then what do you do next here? We're going to collect like terms. We have collecting like terms. We're going to collect like terms. Which like terms are we collecting? We have ax squared. That's the only value that have x squared. So that's what we have a x squared. Of course, that's the only value that have a x squared. But we have a 2ax and we have bx. So the positive b will come first before the a, because factorizing the x out, we're going to have b comes first. B negative 2a, all x out, because those two values have the value of x. Then the next term we have constant, grouping them, we have a negative b, a negative b plus c, right? So we have grouped those constants together. So that was the concept. We collected like terms, a x squared plus b negative 2a all in x plus a negative b plus c. Comparing it with what we have earlier, which is 5x negative 7, we're going to equate the coefficient of both sides because that's what the method is equating. Method of equating the coefficients. So we're going to equate for x. So we're starting for x squared. So for x squared, we notice that, see, for x squared 0 plus this, we can assume that we have 0x squared as one of the value, but 0 multiplied by x squared is 0. So when we're equating the coefficients, taking this and this, we'll notice that a is equal to 0 because the coefficient of x squared is what, 0. So for that, we have a is equal to 0 because the coefficient of x squared is 0, right? So if you do that, so for let's compare for x. Comparing for x, we see that 5 is equal to what? A negative, sorry, 5 is equal to what? B negative 2a. But we say that a is equal to 0, right? So bringing that, we have that 5 is equal to b negative 0, so b is equal to 5, right? Then comparing for c, so we can, what do you notice here? That's negative 7. So for the constant c, what do you notice? Negative 7 is equal to what? A negative b plus c. So we know that a is 0 and b is 5. So we have negative 7 is equal to 0, negative 5 plus c. Making c solve formula is moving this to the other side, which is negative 7 plus 5. So c is equal to what? Negative 2. So therefore, we're getting the value of a, b, and c. So therefore, we're going to substitute this into what? Our assumed partial fraction. Say this is 5x negative 7 over what? X negative 1 cube is equal now to equals to a. So a is 0 over what? X negative 1 plus what? B is what? 5. So we have 5 over what? X negative 1 squared. Then we have negative 2, which is negative 2 over what? X1 all cube. What do you notice? This will go out. So you just have 5x negative 7 over what? X negative 1 cube is equal to what? 5 over x negative 1 squared negative 2 over x negative 1 all cube. So this is the method of finding this using the repeated linear factor. Thank you very much.